Okay, so let's jump to the first example. Hopefully it's not lagging. It's kind of lagging a little bit, but that's hopefully it's good. Okay. So the first example, I have something that I have 1 over x minus 2 plus 1 over x minus 1 less than equal to 1 over x. Of course, the solution of inequality, any inequality, is going to be in interval notation, and because inequality, it has so many solutions. Okay, infinite many solutions. And you see that if you change this less than equal sign here and you put it equal sign, it become rational equation, right? So the rational equation and the inequality, the equation and inequality is nothing but the number of solution is different. The second difference is that it's just the sign, right? Instead of equal sign, you have less than, greater than, or less than equal, greater than equal. Okay. So we try to factor according to general approach. Say I try to factor everything out, but over here we cannot factor anything, so we'll just leave it like that. Then we're gonna move everything to the left hand side. So I'm gonna move everything to the left hand side. I set 0 on the right hand side. Okay, I said less than 0 on the right hand side. Then we have to find LCD. Okay, so maybe over here I missed a little, so find LCD. Okay, I'm gonna find LCD for all of this, so I'm gonna find LCD for all 3 fractions. Okay, so everybody know how to find LCDs. I'm not gonna go through that so much. The LCD over here is this. So we'll have x minus 2 here, and minus x minus 1, x minus 2, and that's equal 0. Okay, so that is fine. That is LCD. That is LCD of this rational expression. Okay, then you're gonna distribute it and see if we can try simplify the top or not. Okay, so you can have x squared minus x plus x squared minus 2x over here is store forward, so you have minus x squared, so a negative x squared minus negative 3x squared, so negative data become 3x squared, negative times negative positive 2 minus 2. Okay. Excuse me. Then I have the bottom is this. That's equal to 0, right? Okay. Then what? I'm gonna simplify them. So x squared minus x squared is so 3x squared plus this is 4x squared minus x minus going to be negative 3x, right? Negative 3x and minus 2 here. Okay. Now what we have on the top, we have everything's be in factor form so that we can use the side table. Okay. So for x squared minus 3x minus 2, if you factor them out, let me do it really quick here. Hold on. Let's see what happened. Okay. Oh, we cannot factor this. Let me see, I messed up anything or not, because if we cannot factor this, then we have to use quadratic formula. So maybe I messed up over here. Let me check one more time. Okay. All right. So you have x squared minus 2x minus x plus 2, so x squared minus 3x plus 2, so you have negative x squared plus 3x minus 2, 3x squared, oh, right here, so 3x. See, I have careless mistake. So we here, so you have x squared only, right? And negative x, so whenever it's negative 2x, so this is cancelled out. so it's cancel out, right? So that's we don't have this term anymore. So all we have is x squared minus 2. Yes, we just have x squared minus 2. Alright, so let's rewrite it. So you have x squared minus 2 over x minus 2, x minus 1. That's equal to 0. Okay. So everything must be in factor form, right? So it look like the bottom is in factor form already. But think that's, can we factor the top one? Can we factor the top one? If you guys remember the difference of square, so a squared minus b squared equal to a plus b times a minus b. So you see the square root of 2. 2 is the same as square root of 2 squared, right? So I can rewrite 2, so x squared minus square root of 2 squared, because square root of 2 squared gives you 2. So I can apply the difference of square. So I can apply, so it become x plus square root of 2 times x minus square root of 2 over x minus 2, x minus 1, less equal to 0. Okay, so now what, everything in factor form already, because everything in factor form you can put the 0, you can put the value of each factor on the number line. But how you gonna find those values? Very easy, you know, just solve for it. So you're gonna put x equal to 0, x minus 2 equal to 0, x minus 1 equals 0, x plus square root of 2 equal to 0, x minus square root of 2 equal to 0. So you're gonna solve for that. So you have x equal 2, x equal 1, so x equal minus square root of 2, x equals square root of 2. Okay, so these are value we're gonna put on the number line. So if you ask me what value you should put on, you just set it, each of them equal to 0, and you solve for those value, and those value will be on the number line. So I'm gonna put the number line here. So this is the sign table. Okay, so this is the last step of the general approach. So of course you have to put everything in order. So negative square root 2 must be on the left hand side, right? Then you have 0 over here, and you have 1 over here. Square root of 2 is 1.41, so square root of 2 must be over here, and you have 2 on the way to the right hand side. So how many interval we have? 1 2 3 4 5 6 interval. Okay, so we're going to pick a value in each interval. Alright, you pick a value in each interval, because you have 1 2 3 4 5 6 intervals. So 1 2 3 4 5 6 interval, right? So you're going to pick a value in each interval, any value you want for each interval. You're going to plug it in here. Okay, you're going to plug it in here, and you plug it in here, you have to see that it is positive or negative. Okay, so I'm going to plug the value of 3, right? You plug the 3 over here, plug 3 over here, 3 3 3 3 3. So it looks like positive, so this plus. Now between square root of 2 and 2, you're gonna plug a value. You can put over here. Maybe I'm gonna put 1.5, right? 1.5. 1.41 over here, 1.5 level, or maybe 1.9, something like that. You plug it over here, give you negative, and you do the same thing for all of them. So you be positive, negative, positive, negative. Okay, and now what happened? You have to be careful, because at the bottom in the polynomial we don't have to care. We don't have to worry too much about the bottom, because we didn't have it. But in rational equation we had to worry about the bottom, because you see that at the bottom over here, all the value over here, it cannot be defined as 0. You see the value 0, the value of 2, the value of 1 over here. If you plug those value in the x at the bottom here, it becomes 0 on the denominator. It's undefined, right? So those value is undefined. Okay, it's undefined. Okay, it means that we cannot use the bracket. We cannot use the bracket for that. Okay, because it's undefined. Other than that, everything must be bracket. Okay, okay. So our final solution will be what? Because we want less than equal to 0, so all the plus sign will be thrown away, all the plus away, because we want the negative sign because it's less than 0. So our solution will be what? Negative infinity to negative 2. Usually it must be bracket because it's equal sign, right? But because we don't, oh yes, negative 2. Oh, negative 2 is still satisfied. Okay, so this is must be bracket, right? Because it's less than equal. But okay, union with, usually for 0 we have to put bracket 2, mean we include 0. However, look like if you plug 0 over here, it undefined, so you have put parentheses. And same thing for parentheses for 1, and union with bracket square root of 2. Square root of 2 works, so it will be square root of 2 bracket and to 2 parentheses. Right, so we're gonna pick 1, 2, 3 solution, 3 interval only, because we want everything less than 0. Okay, if it is greater than, we throw it away. Okay, so this is our final answer. Okay, maybe I mean, hopefully you guys can follow me. I'm gonna give you another example, but as you said, it's not really that bad. I mean, you just it's kind of logical a little bit over here. Okay, but you at the beginning, the first 4 or 5 steps, you try to follow the routine, but over here the number line, if you're good when you solve polynomial inequality, you should be okay over here. Okay, if you can grasp polynomial inequality, then over here it's not really that bad. All right. All right, let's do another one. What if I give you something like this? What if I have this? Okay. What if I have 2x squared plus 3x minus 5 over and x minus 2? Some of the students do like that. Some of the students, they just like they cross multiply over here, and they start solving like you solve linear equation or quadratic equation, but it's not equation. You have to use. So remember, for anything that is not linear and inequality, then you have to use the sign table. You don't have a very traditional way for solving non-linear inequality. Okay, you have to use the sign table. Okay, you have to. Alright, you know, the basic inequality you already learned is the quadratic inequality that we have also used the sign table. But of course, rational is not linear, so it's a curve. So you have to use the sign table. Okay, so let's apply the general approach for this, which is you're gonna bring everything to the left hand side. Okay. Then find LCD. Okay, for LCD. Okay, you multiply the top and bottom by x plus 1 over here. LCD. Then simplify the top. Okay, so you have x, x, negative x, so it will be plus x. Negative times 1 is negative 2, negative plus 2. Okay, 3x plus x is 4x minus 5 plus 2 is negative 3. X plus 1. Okay, now we're going to factor everything out. So you have x minus 3, and can we factor this or not? Because we want 4x over here, so oh, look like this is not factorable. If it is not factorable, again we have to go back and check if we have any careless mistake or not. So you have over here, you distribute it, right? So I just want to check it again if I distribute them right. Plus x minus 2, x minus 2, so you have x squared minus x minus 2, so you'll be x squared plus x plus 2. It looks like it's good. Look like it's good. Alright, so you have x squared plus 4x minus 3. Okay, x squared 4x minus 3 over x plus 1. And look like we cannot factor this. Yep, we cannot factor this. And if we cannot factor this, it means that we have to use quadratic formula. Okay, we have to use quadratic formula. So I'm gonna set x plus 1 equals 0 so that I know the value. I put it on the number line. Okay, then I set x squared plus 4x minus 3 equals 0, so I'm going to use quadratic formulas. The reason I have to do that because I need to find the value I put on the number line. So I'm going to find it. So x equal to minus b plus minus square root of b squared 16 minus 4 a c. Big number, guys. So you're going to have negative 4 plus minus 16 plus 12, right, over 2. So you have negative 4 plus minus square root of 28 over 2. So it could be in negative 4 plus minus 2 square root of 7, right, over 2. As simplified, it gives you negative 2 plus minus square root of 7. Okay, square root of 7. So now what we have two values I put on the number line. We have another value we put on the number line. So totally we have 3 values I put on the number line. Okay, so you have negative 1, negative 2 minus 7. So negative 2 minus square root of 7 is all the way to the left because that's the smallest one, right? Then negative 1. Then you have negative 2 plus square root of 7. Let me see, between negative 2 plus square root of 7 and negative 1, which one is bigger? Probably I just the order is wrong here. I should put this on the left and negative 1 on the right. But let me say, I'm going to use calculator already. So square root of 7 minus 2 give you what? Square root of 7 minus 2. Oh yes, so 0.6 is good. It's greater than negative 1, so everything is good. Okay, everything is good. Alright, so the order is correct. So you have 1, 2, 3, 4 intervals. So we're gonna 4 interval. We try to plug it in, and you see that at negative 1 is undefined over here. So it's undefined at negative 1. Okay, so we have 4 interval. So I plug the value. I pick a value inside those intervals. I plug it in and see which one. So I'm going to plug into this one. So I'm going to, first of all, I'm over here and plug it like I don't know. You can plug like 3. You plug it here, it's give you positive. Right? First of all, 3, right? 3, 3, 3, 3. Yeah, of course, positive. And you plug between negative 1 and this, right? Between negative 1 and 0.6, right? You calculate this out. This is 0.6. So you can put 0 here. So yeah, 0, negative, right? And over here you can put negative 2, negative 2, negative 2 squares 4, negative 2, 8, negative 8. So this will be negative 2, negative, negative, positive, right? And this is negative. You're gonna plug in the value, okay? And you want everything less than 0, so you're gonna throw away all the one that's greater than. So only less than is the one we we taken. So our solution will be negative infinity to negative 2 minus square root of 7, and we have to use parentheses because usually you see the original question is less than, there's no equal sign. If it's the equal sign, we have to use bracket. Okay, union with. Okay, of course over here doesn't matter it's equal sign or not, doesn't have equal sign because this is undefined over here, so we have to use the parentheses, negative 1 to negative 2 plus square root 0. There you go. So this is your final answer. Okay, so that is how you solve a rational inequality. You have to use the sign table. So I'm gonna give you another example, and in this example I want you to practice for yourself. Okay, I'm not gonna do it, but I mean, if you come, if you couldn't figure it out and you try to come and ask me in class or in on campus, I don't mind show you how to do it. Okay, but I want you guys to practice this one for yourself. Okay, so something like this. You'll have I have this. But if I have x squared minus 3x plus 4 greater than equal to negative 4 over x minus 4. Okay, so go ahead, practice this example for yourself. You do the same thing. Okay, you move everything to the left hand side, try to factor LCD and find the value you have to plug in on the number line. You have those value. You know, if you cannot factor, then you have to do quadratic, but hopefully you can factor this time. Okay, if you get stuck, you have to let me know. Okay, you let me know if you want me to go through this or not. Okay, but this is your practice problem for you to have fun with linear rational inequality. So I'm gonna stop the video today. So you see that I'm gonna split this video into two parts. It kind of very high definition, so it took me a while to post it, so I'm gonna split it up. Yeah, so go ahead, watch it and try to understand each example. Practice on the homework. Practice on the example I give you here. Then if you have any question, please get back to me as soon as possible. Alright, then I'll see you this next time in the next chapter, in the next section. Okay, bye bye.